times, or if you're absent, you have a refresher. We'll see how this works. I don't know if this microphone was the only one they had at Altex. It only cost $8, so we'll see. Maybe mumbly. But, so we're going to talk about wood, heavy timber construction, and I want to sort of go through the discussion questions in the back of the chapter just to refresh you. The first one is, let me get to that right page. The first one, it's on page 159 if you have your book. Why does heavy timber construction receive relatively favorable treatment from building codes and insurance companies? Does anybody remember why that is?
It burns slower.
It burns slower, that's right. And because it's so heavy that a lot of times the outside will just get charred and the inside is still just fine and you can sand it off. So it can be rated for fire-resistant construction if done properly. There's rules to go by, and I went through that in the chapter. In your floor systems have to be open; it can't be concealed. Stuff in your ceilings, so you have to follow those guidelines. But you can't have a fire-resistant or fire-rated construction with heavy timber. And the second question was, what are the important factors in detailing the junction of a wood beam with a masonry loading wall? Does anybody remember that?
I went over that. I couldn't find it, but I found the page for it. It's like
Well,
I think it was 148.
Here's the slide on it. You said 148?
Yeah.
Well, I think it's covered in several pages. But before that, where it's shown in this, actually this is the slide I want you to see. There. It's shown in that slide, which is on the PDF that was on Canvas. You can see that the beam is anchored to the wall. There's a space all around it to allow air circulation, and then this one is not fire cut, but these, when the wall goes above it, is showing how it's fire cut and it can rotate out without busting the wall down, because you want your exterior wall to stay put. So if it's not fire cut, you see how it tips up there. If it is fire cut, it will just rotate out. And then the other important thing, of course, is this air. Of course, this concrete doesn't go over it, so this one doesn't have to be fire cut. It could rotate on its own. And then it's not fastened to this clip angle here either. That's an important point, because you want it to be able to fall out, but you also need it to be able to move and to breathe and expand and contract. So you just want that to kind of guide it and hold it in place. So that's an important, very important aspect of heavy timber construction, is how they're fastened. The third question was, draw from memory one or two typical details for the intersection of a wood column with a floor of a building in heavy timber construction. And that's shown up here in the slides. And you can see this is a contemporary column connection with bearing blocks or split rings, which they talked about using in wood. And the beam ends are not supported on the cross grain material. So you can see there's the strap and the beams butt up to the column like that. Here's another good detail, and I think that's in the book too, on how you would connect beams to wood heavy timber construction columns. Is there any questions on that? Yeah?
For different question, while I drive on the road, I saw construction building with a wood beam.
Mm-hmm.
For example, yesterday, 2 days ago, it rained a lot.
Mm-hmm.
So how to continue to construct the
When it's all wet?
wet wood?
I always often wonder that too. When they were building my house, I was like, soaking wet. But they have to allow it to dry out before they enclose it. Like that structure was probably still wide open. So once the sun comes out, it'll dry. As long as, if it's good wood, like lulams and heavy timber, real 2x4s, stuff like that, it'll be fine. If it's plywood or stuff that will warp and distort, then it would probably need to be replaced. And that's something that, they'll just have to let it dry out good before they put the wrap on the building and the shingles and make it airtight. So, and the engineer who's watching the construction would usually go out there and tell them when it's okay or if they have to replace something because it has water damage. So, any other questions? No? Okay, let me see if there's any other high points.
On that video of Dubai,
Mm-hmm.
I looked on more stuff on Dubai or whatever,
Uh-huh.
and it talked about how they wanted to build that mall in 28 months, and they ended up finishing it in like 34 months.
That's not too bad.
Yeah, but it's huge.
I was like, my brother actually went to the Burj Dubai. Have any of y'all watched those videos I put on there? They're attached to the lectures. But it's an amazing structure. I have a picture of him at the bottom of it. And it's just, I don't know if I'd want to be in the top of that building in the first place. But, because I think that you would like go back with the wind. But it's an interesting, the same thing. I was watching the news this morning with the 9/11 stuff and the stuff, how that, the reason we build buildings the way we do now is because of what happened in 9/11. There's been a lot of new codes and fire issues and, steel, you think steel is indestructible, but it melts, and that's what happened. The flames melted the steel and it couldn't hold it up anymore, so it all collapsed. And so now in the Burj Dubai, you can see that they have, I think they talked about having rooms where you could go that are all, where people can go to, like in parts of the building, like every 5 floors or something, I don't remember, but in the escape fire, they wrap the steel, they fireproof it. There's just a lot of thought goes into how, of course nobody could predict what would happen then, so there's going to be something else that's going to happen maybe that we can't predict, but we can try our best. So, back to wood though. Any other wood questions? Okay. Do any of you remember in your reading why long laminated wood beams are often spliced between columns rather than at columns? Let me see if there's a slide on that. I don't know. You would think they'd be spliced at columns. I mean, your brain would tell you that, but it's not true. I don't see a slide depicting why that is, but the reason is because splicing the beams with a hinge connection at the point where you want to do it at 0 moment. So we haven't really studied moments. You'll do that in another class. But if you have a beam, actually, I should draw it on here so people can see it online. Let me try this. Bear with me. Where's that little pencil? We got all this stuff and we got to learn to use it. So if you have can't draw very good on here, but you have these columns and they're supporting a big glulam beam, splicing them with hinge connections at points of zero moment, the bending action of each beam can be made fully continuous, which results in maximum structural economy by minimizing the size of the beam. So you want to splice them in the middle because that, you gotta, this pushes up, so it's automatically, like if you were looking at the action in the beam, it's automatically kind of going like that. So there's least amount of pressure here, so if you splice it here, it'll be stronger and you can have a smaller beam. Make sense? It will someday. Oh, I don't need that erase. Now I gotta figure out how to erase. Okay. Hold on. I'll get this system sometime. See an eraser on here?
Flick manual?
No. Maybe I can make a new page.
Toolbox?
Where's the toolbox?
Fourth one.
Huh?
The fourth one?
That?
The fourth one down.
Upper right,
The
left.
fourth. To the right. The fourth one.
That? No, that's not it. You know, it's easy. I just can't.
Try the one to the left of that. Oh, no, never mind.
I wish it was like my iPad and I could just go like that.
Exit out. On top. Yeah. Try the tools up on the top left. The file. The hand.
Oh well, I'll have to play with this some other time. Where's my eraser?
Oh.
That's cool. Okay. Done. Come on. Let's see. What other questions can I ask you? So tell me if this is true or false. Floor construction in heavy timber buildings may not have any internal cavities. Is that true or false?
True.
True. Why?
Which one?
Well, you don't have this one in your book. It says floor construction in heavy timber building may not have any internal cavities. So you were just guessing. You had a 50-50 shot when you said true. Has to do with fire. I mentioned it earlier. You have to be able to see basically all the parts of the construction, and air has to flow freely. You can't have, like you couldn't have a ceiling like this with something above it, because we would never know if smoke was going on in there, and the fire would spread before we could do anything about it. So heavy timber cannot have any concealed internal cavities. That's what internal cavities means, like concealed spaces. Any other, let's see. Let me see if there's any other things on here I want to show you or highlight. I'm not going to go through the whole thing. It was a, you know, the earliest form of construction. You should have seen all that. This is a good drawing to study. Because it shows a lot about how it's joined together, and you got to, I mean, you could draw a portion of this for one of your details. You've got the columns, and I think this drawing's in your book too, how they rest, and then the floor joist and whatnot. So that's a good drawing to study. There's the code issues with it, how it's rated. We already saw that. This is showing the floor and roof decks. You got the tongue and groove at the top, which we had a piece of that when we had the wood out here. You got laminated, which is little pieces put together, and the third one down, and you have another form of laminated right here. There's a picture of a floor and a roof deck, and you can see how it's all open. All the wires and stuff that are in your ceiling have to be exposed, so that has to be done neatly when you do it that way. There's a frame of a heavy timber building all put up, and then they'll cover it with siding or stucco or whatever later. But that's a good picture. Sometimes we go back and add new bracing to old buildings, and that's what's happened here. Because we have stronger codes now, and we want to be able to keep them safe and people to still use them. There's another picture of the open ceilings and how you'd have to do the air conditioning. It would all be exposed, so it has to be nice and neat. Connections typically is mortise and tenon, which is shown here. You didn't use nails back in the olden days. You used wood to connect wood. This is a more modern connection with the drilling dowels and concealed steel plates. So you don't really see the connection, but it's very strong. You got steel within it. So here's another form of connection. More. Y'all can look at all this on your own time. And you can do some pretty cool things with glue lam because you can bend it, and it's very strong, as you can see here. It makes a big space. So that's that. Now, is there any other questions? We're going to do this exercise together. Unless there's questions. Okay, hand this out. You need to do this for your assignment grade, even though we'll probably get done with it in class. If you don't, you can turn it in next time. Yeah, we're going to draw on here. So give me attention. Everybody got one? Okay. So it asks you, to the left, construct a detail of the intersection of a typical beam or girder with the exterior wall. To the right, draw a detail of the intersection of this same member with an interior column. Show the decking and finished flooring on both drawings. And if you look in your book, just 1 second, I'll tell you the page. Because really this is a detail, sorry, is it 146? Yes, exactly. You can see in the book on page 146, you got a whole wall there. We're just looking at a small portion of the wall, and it's not really the same type of wall, but this is where we're going to get a lot of our information. So they have the wall, and they have the beam connecting to the wall, which will be the left-hand side of our drawing. Then they have these marks called cut marks. So you're really not seeing, the 100 feet between, or the 50 feet between the wall and the column. So you've got the column to the right, and that'll be the right side of our detail. So that's, if you don't understand how details work, you're cutting a section, magic pencil. Normal pen. Okay. So when you draw, like if you're looking at a building, I'm going to draw a square building, just for simplicity's sake, and it's got some masonry walls in it that this situation, we're kind of looking at this part of the wall. Then we don't care about what's going on in here, but then we want to look at that part. So on our little sheet of paper, you have on the right side, you have this wall, which will be here, and then you got the center line, which is what that indicates through the middle, and you're going to show this connection here. So that's what that, does that explain to you how we're looking at this? Everybody understand that? Okay. Erase it again. Now, I'm going to try to draw kind of what they have here, just to get started. When you cut something, wish I could make the pen thinner.
How far is your lead to that little dial?
That?
Yeah. Try to go small.
Yeah, that's better. Thank you. Alright. So I'm going to try to draw what you're seeing on your piece of paper. They got your section mark there. Then it's drawing not the masonry pieces. Try to do it sort of the same scale. If you look on your drawing, it says 1.5 inch equals 1 foot, or 1 square. If you can see the little squares, 1 square equals 2 inches. So that's how you can kind of scale it by this when we get into drawing things. So these bricks, if 1 square is 2 inches, these bricks are approximately 2, 4, 6, 8 inches tall, or these blocks are 8 inches tall. So anyway, going up there, and then we got one down here. So that's what they give you on that side. And then on this side, you have another cut line, meaning that that keeps going on and on. And then you got your center line of your column, which is drawn like a line with a dot, a line with a dot, on down. And then there's another cut line down here. That's all they've given us. So to the left, construct the detail of the intersection of a typical beam or girder with an exterior wall. To the right, draw the detail of the intersection of this same member with the interior column. Show the decking and the finished flooring in both images. So we're going to have the beam intersecting the wall first. What do you think, what do we have to do to this beam so that it won't
I'll fire cut it.
fire cut it? Excellent. Let me see. So the beam is going to rest. There's going to be an anchor somewhere about in here. It's going to hold the bottom of the beam. It'll have bolts through it, sort of like that. And then your beam is going to be inside of that, and it's going to be fire cut, slanted like we saw before. And then it'll go back over, all the way over there. We'll finish that in a second. So beyond that, you would see the bricks beyond it. These bricks are actually going to be cut. It's hard to draw on here, but you get the picture. So y'all should be drawing this on your little detail too. Neater than I am. So your beam will be fire cut. Then, so you have this is a metal anchor that holds it into there, and then you got your grout in all of these. So all of that's grouted in, which is like the cement. So since that's sitting on there, these down here don't have to be cut anymore, so you can finish them out. So there's your edge of your beam. got your beam. You got a beam going this way. I'm just gonna draw one line. That's so beam going that way, and then you've got these other beams that are going, and the rest. That's hard to see that. The resting. Hold on. Okay. Right again. You got a column. You got a major beam that supports that, the rest on there and there, and it supports that. Then you got the beam that we're drawing. Our section is looking this way. We're drawing, it comes there, and then it's not lined up. It's hard to do that. But so this glue lamb is a major support, and these are minor supports that rest on the glue lamb with straps. So the glue lamb, the top of the glue lamb obviously is going to be at the same height as the beam. So we can take that all the way across. And we know that our glue lamb is going to be something like, it's going to be bigger than that. So we're going to draw it a little bit bigger. And then a glue lamb is what is it? It's lots of pieces of wood glued together. So you can just draw a bunch of wood, and then you attach them to different ways, so you can indicate that it's a glue lamp. And it'd probably be, they don't give us any sizes of anything, so I don't think. But I would make it maybe like 6 by, so I don't have squares up here to look at, but I would make it about 5 or 6 inches wide by 18 inches deep on your drawing, which you can count the squares. The squares equals to 2 inches, so it'd be 9 squares. 2.5 squares by 9 squares would be about the right size. So you got your glue lamb. Then that's going to rest right on whatever post is underneath it. It's going to rest right on top of that. And then there'll be some supports. They call them bearing blocks. This is going to come to here, so we know where that ends. And then there'll be another one on the other side. But so how does that stay there? There's going to be these things called bearing blocks that come down and are anchored with bolts into, or split ring connectors we talked about in the chapter. So that's how, that's one big connection all the way through, and then there's going to be another one up here going all the way through, and then something right there to keep it. So these are bearing blocks, which are made of wood too, that are like chunks of wood, probably as nearly as wide as the column, that come up, and then this beam can rest on there. So that's how it's supported. In addition to that, you don't want the beam flopping around, so you're going to have some tie straps, which are just little metal straps, and that would be nailed or screwed in, and it would also come this way on the beam, come towards us, and there would be nails or screws there, and you'll have that on each side. Draw your little nails like that. And depending on the size of the wood, those will be bolts or nails or screws, whatever's required by the engineer. Then the decking, they want us to use tongue and groove decking. So, let me, if I get that, it's the wood. This is what they're talking about, tongue and groove. So this is the tongue, that's the groove. And you put those in to there, and then they're locked in place. So they want us to draw tongue and groove decking across the top of this. Boom, 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 boom. So you need to draw this shape all the way across. And this is about, for scale purposes, 5 inches by 1.5 inches, or 2 inches. So on your drawing, that would be probably almost a block high and 2.5 blocks long, or squares long. So anyway, you just draw your little over and over again. It's very hard to do that on here. It's not further away. You draw it all the way across. Of course, they'll be all even on top, not like what I'm doing.
And those are called what again?
Tongue and groove decking. And that provides a very stable, fire-resistant floor for heavy wood timber construction.
What is it called?
Tongue and groove decking. T-O-U, like your tongue, and groove. It just goes on and on across the whole building. Put it here. But on top, that's not your floor. You're going to have a finished, I mean, that's the floor decking. You're going to have finished flooring above that, which, depending on what's in the building, depending on what the floor is, but you'll probably have some 3/4 inch plywood, which will be about half a square tall in your drawing. And that will just be nailed all the way across the top of that. And plywood is generally shown, I'll draw a big piece of plywood here, like it would be drawn with lines through it like that, and then you'll have hash marks like that. That indicates plywood. So you got, it's hard for me to do that on here. I'll draw one line through it. Hash marks. And so you'll label this. T and G is short for tongue and groove. So you can just write T and G decking. And then up here you can call this your 3/4 inch flooring. And on top of that, they may put like vinyl tile or carpet or whatever. So that's pretty much it. You got your fire cut beam. You probably should label that. That's important to remember. Why? Why is it fire cut? So it can roll out and break away. You got your bearing blocks. You got your column with your bearing blocks. Your girder sitting on top of that. Your beam strapped into it. questions on that, or y'all need a few minutes to finish that? What?
Yeah.
Okay. I'll rest a minute. Anybody come in that hadn't done the sign-in sheet? Did you get the announcement that you could take the test?
Yes.
You can also do extra credit for called out in the cell list. Frankie, here. I'm just gonna hand this back. Is that you? On the exercise, on the homework, I don't really like check it. We'll go over it. Finish board, sorry. Very hard to write on that. Daniel, here. Suppose I could use a keyboard. I'll try that next